Hello class. In this video, I'm going to demonstrate process capability and why it's important to be able to satisfy customers' demands and requirements. So this is problem 41 in supplement to chapter 6. It says, Meena Chavan's corporation's computer chip production process yields DRAM chips with an average life of 1800 hours and a standard deviation of 100 hours. The tolerance upper and lower specification limits are 2400 hours and 1600 hours respectively. In this process, is this process capable of producing the chips to specification? So when you're using process capability or when you're monitoring quality, it's not only whether you're making processes or you're making products that are within control limits. What you must do is to also make sure that your process meets the customer specifications. And that's what process capability does. Now, there are two measures of capability that we generally discuss. One is called a capability ratio, or C sub P, that you must compute. The other one is capability index, which we call C sub PK. Now, to compute C sub PK, there are two other indexes that you must compute. I call them CPU and CPL. And the capability index is really the minimum of those two. CPK is minimum of these two. Now, in most problems that you may have on a homework or exam, you will be told exactly whether to compute CP or CPK. But in this problem, as I read it, it's really left open and you're told to make a determination whether the process is capable. So what we need to do is to compute both the CP and the CPK. So let's start with CP. As your book says, to compute CP, you must take the upper specification limit, that's the customer's tolerance, minus the lower specification limit, and you divide it by 6 times standard deviation. Now notice in this equation right here, the process average is nowhere in this equation. So this capability ratio, C sub P, only addresses variability of process. And it essentially tells us whether the variability is acceptable relative to the tolerance or specification dictated by the customer. So to put these numbers in for this problem, we know upper specification is 2400. We subtract from it the lower specification. So we essentially know we want to see what's the spread in the specification. And then we divide it by 6 times 100, which is 100, the problem tells us, is the standard deviation. So this turns out to be 1.33. And with this being 1.33, as long as you're at least 1 or higher, then your process variability is acceptable. So in this case, because C sub P is greater than 1, then variability of the process is acceptable relative to the specifications, relative to specs. Okay, but the question is now, what about the mean of the process? What about the process average or the central tendency of it? As I said, CP does not address the center of the process at all. Um, so what we need to do is to compute C sub pk, or what we call the capability index. Now, in order to compute the capability index, you need to compute two different indexes. One is CPU, and that's essentially your upper spec limit minus x bar minus the process average divided by 3 times standard deviation. So for this process, for this example, it's 2400 minus 1800 divided by 3 times 100, which in this case happens to be 2. So that's good, that's very high. But there's also, you must also compute a CPL for the lower spec limit and see what the process average is doing relative to the lower spec limit. So in order to do that, you take the x bar, or the process average, subtract from it the lower spec limit, and divide by 3 times standard deviation. So for this problem, it's going to be the 1800, which is the lower spec limit, minus the 1600, which is the process average, divided by 3 times 100, which is 3 times standard deviation. And this happens to be 0.67 for this problem. So a much lower number. Now, CPK, we compute CPK by computing both of those, and then CPK is the minimum of the two. Minimum of CPL and CPU. So in this case, the minimum of either 0. Let me erase that. Okay, the minimum of 0.67 or 2, of course, is 0.67. So this is our capability index, which essentially tells us about the center of the process. So let's understand that. There is this figure that helps us understand and interpret CPK. So, excuse me. So this is where CPK is equal to 1. When CPK is equal to 1, the process variability or variation, or the spread of the data, of the process, sorry, is within the spec limits. And the center of the process is also in the middle, right in the middle between the spec limits. So that's good, that's acceptable. We call that acceptable. If CPK is greater than 1, so 1.33, 1.67, or 2.0, then that's really, really good. Process is better than the specification even requires. And that would be the situation right here, where you can see that the process variability from here to here is way within the spec limits, which are over here. So you have all this much cushion from what you are performing to what your customer is expecting. Okay, so 1.33 for CPK means 4 sigma. 1.67 means 5 sigma. And 2 means 6 sigma. This is where Motorola is, and 6 sigma, and everything that you studied back in chapter 6. Here, when CPK is equal to 1, we're looking at a 3 sigma process. Now, what if CPK, like in this case, our CPK was 0.67, right? So that's where CPK is between 0 and 1. Notice that in this case, process variation process mean brings us outside of the spec limits. So here are the spec limits right here and right here. And this part of our process is outside of the spec limits, and our center of the process is closer to the lower spec limit, and it's farther away from the upper spec limit. When CPK is 0, the process average is right at the upper end of the spec limit. And when CPK is negative, then your process average is outside of the upper spec limit. So that's how you interpret these things. So essentially, CP, the capability ratio, you want it to be at least 1. If it's not 1, then you know that your variability is not acceptable. And then CPK is your capability index, and these are the interpretations for it right here. You want it to at least be a 1 or higher, as indicated in this case and this case, but anything other than that, 0, less than 0, negative, or less than 1 is really a not acceptable situation to be in. So that is process capability, and why it's important to monitor the capability of your process so that you can satisfy the needs of the customers and their specifications, and not have so much scrap, rework, rejects, etc. by your customers. Thank you.